David Smith here with one more Flipped Classroom math video. 3 tips before we start. You could turn on the captions and watch my words go by on the screen, if that helps. You could also speed up the playback if you can get through the video faster and still comprehend. Lastly, you could pause video at any time and catch up on your notes. So today's lesson covers integrals and areas. So this is one of the fundamental things about calculus that you get to do. We're going to approach this in a step-by-step process, first starting with a geometric method, and then we're going to get to continuous functions and the fundamental theorem of calculus, which is pretty cool stuff. But we're going to approach that with a couple what I would consider baby steps. So check this out. I have a graph here, and I have basically this rectangle in here, this shaded area. Let's go ahead and shade her up. Okay, now let's find out that area. And this is actually what we're going to use with integrals. We're going to find area under curves, which is not, you can't do this by using the formula for a rectangle. But let's do that in this case. So go ahead, pause the video, write a plug-in step with the area for a rectangle and calculate the area of this rectangle. Okay, so the area of rectangle is just length times width. We can get that information off of our graph here. We know that our length could be height, but I'm calling it length. Here in this case, it's going from 0 to 4 on the y-axis. Notice how this top line of our rectangle is the function f of x equals 4. So that's a horizontal line that has a y value of 4 all the time. So that's telling us this distance, which I'm calling the length. So that's length times width. Length is 4. And then our width is 5 because we're going from -3 to 2. And that gets us 5. And so area is 20. Pretty straightforward. In fact, kind of trivial. And I've overcomplicated this problem by explaining it in terms of the graph. You wouldn't need to do that if all you were after was the area. But we're going to do this with calculus. So check this out. Okay. So I wrote this as an integral. And so now we're going to do definite integrals. So we have a range set up here. This is kind of how you write limits as well. So what we're saying is the integral of 4 dx from -3 to +2. So our function is 4 dx. There's no x in here. Y is always 4. So that's our function, 4. We can integrate this from -3 to 2, and we can find out what our area under the curve would be. So let's do that. Okay, so I did this by hand. In a minute, I'm going to have you do this on your calculator. I'm going to put a link in the video below for how to do that. It's really simple on the calculator. So you can actually just put this integral in there, and it will spit out this 20. But we know how to integrate, so we can also do this by hand. And maybe you'll see this problem on a non-calculator portion of your test. So you're going to need to be able to do that. So the integral of 4 dx is 4x. Now I'm going to drop my plus c because I don't need to worry about that because I'm doing a definite integral. So check this out. All I'm going to do to get the area under the curve is, or under the straight line in this case, is subtract this one from that one. So I subtracted, I got my 4 times 2. Here's my function, 4. My x is my 2, this one to the right. So 4 times 2 minus 4 times -3 gives us 8 plus 12, which gives us 20. Now again, this one is so simple that it might be hard to see how we're doing the calculus. So let's do another one. Let's do another geometric example and then take the integral to find our area. So check this one out. I've got a trapezoid that's bounded along the top by this line, f of x equals -1/2 x plus 3. So this is a linear equation, a negatively sloping line, and the area that I'm trying to figure out is from between 1 and 4 here along the x-axis. Now this is just a trapezoid on its side. So I could draw this like so. Okay, so these are my bases, and my height would be this distance here. So I know my height is 3, and then I have B1 and B2 there. So our formula is a little bit different. It's area equals 1/2 height times B1 plus B2. So now we can do a plug-in there for this, area equals 1/2 times height, which is 3. Now B1 and B2 are going to you're going to get those by plugging into the formula, because B1 is this distance from y equals 0 to wherever this is, the y value. So I'm going to plug 1 into my function plus 3. That gives me 2.5 for B1. That's this distance here, which is actually this point there. That's 2.5. And then this one will be 4. I plug 4 in for x, so I get minus 1/2 times 4. That's minus 2 plus 3. That's 1. So I put that in there, and I do my math there, and I'm going to get... So I had to pause for a minute and think about that. Should have been able to do that right on the fly, but I choked. Oh well. So the area is 5.25 units. Now I haven't given you units in this example, so I'm just going to say units squared for the area. Beautiful. Now let's do this as an integral. Okay, so I rephrased this problem as an integral. And again, key point here is the area under a function, in this case the function is a straight line, is the integral of that function with these as our boundaries. So like we're getting definite here. We have a 1 and we have a 4. We're not just integrating this over all of x. It's just between 1 and 4. So we express that with an integral going from 1 to 4, the integral of negative 1/2 x plus 3. So now you can do this one. You have enough information to take the integral of that expression, and then from the last problem, you know what to do to plug in the 1 and 4, subtract, and get your area. And if you do this right, you should wind up right back there. Okay, I took this a couple steps, didn't get all the way to the end yet, so let's see what you get. Okay, here's my problem, my area problem, rephrased as an integral between these two numbers. So reframed as a definite integral. Now I'm going to integrate both these terms using our integration power rule. So I have minus 1/2 times 1 over 1 plus 1 times x to the 1 plus 1 for that term. I did a straight up plug-in step just so you can see all those. And here's my plug-in step for my constant. I wind up with minus x squared over 4 plus 3x, no plus c, because we have a definite integral, so we don't need to worry about that plus c. Now, I did my plug-in step. Now remember, you're subtracting the you're subtracting the left one from the right one. So I'm going to subtract the integral function with 4 put in there. I'm going to subtract from that the same thing with 1 put in there. So here's my plug-in step. I'm using this function right there, and this first square bracket is plugging 4 in, and the second square bracket is plugging 1 in. So take a look at that, see if that makes sense to you, and then if it does, finish that calc and see what you get. Okay, I had a little boo-boo in there just in case you didn't see that. This is minus 1 squared over 4 because that minus is part of our integral function. So I added that in there, and then that impacts what we do next. I just crunched my numbers in there. I have minus 4 plus 12 minus negative 1/4 plus 3. That gives me 8 minus 2.75, and presto, 5.25. Now, you might be saying to yourself, oh my God, this is going to get more and more and more complicated. Guess what? Your calculator will just take this. You could just enter this into your calculator and it will give you this. Okay? I wanted to explain these steps so you could see that we could do this with the integration tools that you already have, with the pen and paper type of style that you have. One last problem. So check this out. Now I've drawn a circle here on my coordinate plane, got my point -4 here, my point 4 there, and then just to be absolutely clear, 1, 2, 3, this is also 4 right there, okay? So here's the function, f of x equals root 16 minus x squared. This is y, remember f of x is y. This comes from solving this equation, this is the circle equation, for y. Y, right, that's y. So we just got y alone, and this is what we get. So you can work that out if you like, but trust me, that's how you do that. So the first prompt here is, what is the area of this shaded region? So let's go ahead and get some shading done here. Okay. Now that's half of a circle. Okay. So what's the area of a circle? Area equals pi r squared. And guess what? We're just going to divide that by 2. And that's going to give us the area of this shaded region, because we know that's 4. So we know this has to be exactly half of the circle. So go ahead, do that calc real quick and come back. Okay, so I just plugged in my 4 for r, squared that, got 16. So I have 16 pi over 2, which is 8 pi. So I like to leave my variables in as long as I can. So then I pull out my calculator and I do 8 times pi and I get 25.1 units squared. So that's the area of the shaded region. Now, I want you to pause the video and write this as an integral problem. Okay, so here we are. It's the integral from -4 to +4 of root 16 minus x squared dx. So now, what I want you to do is go investigate that link below the video there and go ahead and pull out your calculator and put this in there and get the answer. Okay, let's see what you get. All right, I just did this on my calculator on my TI-Nspire. There's quite a few click steps. You got to get the syntax just right, but it spits out this 25.1. I was tempted to do all the algebra on that, but I looked at it. It's like, yeah, we could, but it would take a while. So I didn't. I just used my calculator. So there you go. Now that you've watched the video, take a moment to write down any remaining questions so you can bring them to our next class. Also, remember that you can come back to this video, watch it again if you want to deepen your understanding or fill in any gaps. Lastly, if you enjoyed yourself, please click like or subscribe.